we are actually going to talk about exponential functions, and I'll explain what that is in a minute. And so we're going to do some now, next rules, and tables. Okay, so number 1 says the sequence below shows how many bushes Mitchell's nursery planted each year. 8, 4, 2, 1. Which formula could be used to determine the number of trees the nursery will plant next year? Next, if the number of bushes planted this year now is known. So this was on the midterm. Do y'all remember that? One of these now, next rules. Basically, you just have to figure out the pattern. So from 8 to 4 to 2 to 1, what are they doing every time? They're multiplying by half. They're multiplying by half, okay? And you can just test your answer choices on this one. For instance, B says you're multiplying by what? 2. If you start with 8 and you multiply it by 2, do you get 4? No. C, well, and adding 4 to it. We're not doing that. And D says minusing 4. So look at this. Look right here real quick. D says you're minusing 4. So you got 8. What's 8 minus 4? 4. But what's 4 minus 4? 0. So D doesn't work for all the numbers. Okay, so your answer on this one is what? A. Okay. All right. Back to you in a minute. Okay. Number 2. The sequence below shows the number of trees a nursery plants each year. 2, 8, 32, 128. Which formula could be used to determine the number of trees the nursery will plant next year? Next, if the number of trees planted this year now is known. Okay, so this time we've got the numbers 2 and 8. Let's just talk about that. What are the 2 ways to get from 2 to 8? There's 2 ways to do it. You could times by 4, or you could add 6. What happens if you add 6 to 8? What do you get? 14. So does adding 6 work every time for the pattern? No. Does timesing by 4 work for the pattern? Yes. Okay. Which answer choice says I'm timesing by 4? A. All right, number 3, the sequence below shows the number of baskets made by the South Stokes basketball team, 5, 14, 32, and 68. Which formula can be used to determine the number of baskets made next game next, if the number of baskets made this game now is known? Okay? All right. So let's look at answer choice A. A says you're doing what? Plusing 9. What's 5 plus 9? 14. What's 14 plus 9? So does plusing 9 work to get all the numbers? No. So A doesn't work. Okay? What does B say I'm doing? Times them by 3. What's 5 times 3? 15. Does B work? No. Okay? All right, let's test C. C says I'm going to times by 2 and then add 4. So what's 5 times 2? 10 plus 4? 14. Okay? What's 14 times 2? 28 plus 4? 32. So the answer is C. Okay. Just figuring out the pattern, that's all it is. Okay, the next thing I want you to do is on the side of your notes, there's a box that says linear and exponential. What's the formula for a line? Write that in your box for me, y equals mx plus b. And here's what we're adding to our knowledge today. If it's linear, it goes at a constant rate. So write that down. It goes at a constant rate. What is the shape, what does the graph look like if it's linear? A straight line, okay? What does it mean for something to be constant? It stays the same. So another way to think about it is it goes at the same rate. For example, if you're adding 2, then the next time you will add 2. And then the next time you will add 2. Linear means you do the same thing every time. All right, this is new. For exponential, the formula is y equals, I want to do it exactly like I have it on your formula sheet so I don't confuse you. Okay, A 1 plus or minus r to the x. All right, so that's the formula for exponential. So we are learning a new formula. We're doing a new unit. Here's the difference between these two, the big difference. Where's the x on this one? It's like down low, right? It's a coefficient or beside a coefficient. Where's the x on this one? In the exponent. That's where it gets its name from. It's called an exponential because x is in the exponent. Okay? Another difference is here you are, what's your starting value here? B, because it doesn't have the x. Which one doesn't have the x here? A. So A is your starting value. Here, you're adding your starting value. Here, what are you doing with the starting value? Multiplying it. Okay, so that's another difference. Okay, and we'll do more of that all next week. Exponential has an increasing or decreasing rate. All right, it has an increasing or decreasing rate. So it's not the same every time. It's not the same. It's increasing or decreasing. For example, you might add 2, then you might add 3, then you might add 4, then you might add 5, then you might add 6. Okay? And the graph is a curve. The graph is a curve. Okay, so I know that's a lot to throw at you. Let me show you what it looks like in an actual problem. Okay, so we've got number 4, Alejandro, how do you pronounce that, somebody? Alejandro, thank you. Invested $150 in 2 accounts for 6 years. The ending balances for each year are shown in the table. Which statement best explains why investment B had a larger balance than investment A after 6 years? All right, my answer choices talk about constant rate and exponential rates. Okay, so here's how we do this. We're going to start with investment A, and we're going to figure out what happened each year. So from 150 to 152, how much money went into the account? $2. So do a little arrow and put 2. From 152 to 154, how much money went in the account? 2. And you can subtract those in your calculator if you're not sure where we're getting those from. What about 154 to 156? 2. 156 to 158? 2. 158 to 160? 2. And 160 to 162? 2. Okay, before we move on, we had the same number every time. So this is a constant rate. Write that right beside of it, please. This was a constant rate. If it's constant, does that mean it's going to be linear or exponential? Linear. So let's also write that just so we can practice. So constant rate means it's going to be linear. That doesn't really matter as far as these answer choices, but it's still good to know. So constant rate means it's going to be linear. All right, let's look at investment B. 150 to 151.95. $1.95. You can subtract those in your calculator. All right, what about this next one? 151.95 to 153.93. Y'all got calculators. What is it? $1.98. Okay, good. All right, the next one, 153.93, 155.93. Back up. What did you get after the $1.98? 2. What did you get for the next one? $2.02. The next one? And the last one? Okay. Is this one constant? No, because it's not the same. What's happening to the amount that they're adding in? What's going? It's increasing. So the rate, what you're actually adding in, is increasing. So I know these are increasing, but the number that I'm adding to it is increasing as well. Okay? So that is exponential. All right? That's exponential if the rate constantly goes up. Okay? All right, so let's look. A says the balance for investment B, so this is investment B, grew at a greater constant rate. Was investment B constant? No, so A does not work. Okay. All right, B says the balance for investment B grew at a greater exponential rate. Was B exponential? All right, then balance for investment A. That one, the way it reads, they're making it sound like investment A was also what? Exponential, the way it reads. So let's just keep going, see what we got. C says the balance for investment A grew at a constant rate. Is that true? And investment B grew at a exponential rate. Is that true? Yep, so C is the best answer. C is the best answer. Raise your hand if you have a question. All right. Number 5, Sarah did an experiment to compare two methods of cooling an object. The results are shown in the table below. We don't need to worry about the time. That's just how she kept track of her experiment. What we're really focused on is the method 1 and the method 2. So the two different ways she did the experiment. All right, so for method 1, you need to figure out what it went by every time. What it went by every time. From 50 to 45, how did it change? Minus 5. 45 to 40, minus 5. 40 to 35, and 35 to 30, minus 5. Okay? All right, stop right there. Tell me about this one. What is this? Constant, because it is the same. So how about writing that underneath it? Constant or above it. Find a space to put it. Method 1 is constant. Okay? And if it's constant, is that linear or exponential? Linear. Okay? All right, so method 2, 50 to 36. Yep, down 14. 36 to 30. 30 to 22. And 22 to 9. Okay, everybody look up here. This is new. 14, 6, 8, 13. Is there any sort of pattern to those numbers? No. This one's called neither. This one is neither. Kind of like when we were doing, are they parallel, perpendicular, or neither? Okay. 14, 6, 8, 13. Do those numbers constantly go up? Do they constantly go down? Do they stay the same? No. That one's neither. It's going down, and then it's going back up. So that one's neither. All right, so let's look. A says the temperature using method 1 changed exponentially. Is constant exponential? No. The temperature using method 1 changed at a constant rate. Is that true? Yep. Okay. All right, number 6. The tables below show values for two functions. Which statement about the functions is true? Okay, so I have no idea what it's asking, so let's read my answer choices to help me figure it out. A says the rate of change is the same for both functions. So to get rate of change, you could do y minus y over x minus x. You could also do what we were doing before, okay? Let's do y minus y over x minus x because that always works, and sometimes if they jump around over here, this method isn't always true. Okay, so let's do y minus y over x minus x. Brandon, what would be two y values I could pick? Good. 150 minus 175. And so, Elijah, what would be my x's that go with those? -2 minus -1. All right, Type that in your calculators real quick. So on top you get negative 0.25. What do you get on the bottom? Negative 1. And what happens to a negative or a negative? Positive. Okay. Over here we also have to do the rate of change for this on y minus y over x minus x. Shakira, what do you want to put in for y minus y? Which one? Okay, so 5.75 minus 6. Faith, what would you put on the bottom if you pick those two? Good. All right, what are you getting on top? Thank you. What do you get on bottom? And negative, negative, turn to a positive. So what do you notice? They're the same. The rate of change is the same. I don't need to check any of the other answer choices. I found an answer that works. Okay. All right, just because I'm a teacher and I want to just talk about these real quick. This one says F grows exponentially. From $1.50 to $1.75, it went up how much? 25 cents. What about from $1.75 to 2? 25 cents, 2 to 2.25, and 2.25 to 2.50. So it was constant, not exponential. Okay. I don't want to talk about that one. It'll confuse you. And this one says both functions grow exponentially. That's not true. They're both what? Constant. Okay, good. All right. Number 7, which statement best describes the following table? All right, A says it is linear because it is increasing by a percent. Circle percent and put exponential out to the side. Percents go with exponential functions. So when you see percent, you always want to think exponential. Percent is exponential. Okay, so A says it is linear, and it has a percent as the reason. So that's not even possible. Percent automatically makes it exponential. So you can mark out A. You can mark out A. Linear does not have anything to do with percents. Okay? B says it's exponential because it's increasing by a percent. So does percent go with exponential? Yeah, so that one might be it. Let's keep reading. C, it is linear because it's increasing by a constant rate. Does linear do constant rate? If something's linear, is it going to be constant? Yes. So C might be the answer too. D says it's exponential because it is a constant rate. Does exponential go with constant rate? No. So we know it's not A or D because those don't even fit the definitions. Okay. Okay. If you look right here, you got to be careful on this one. This is the reason I put this one on. This is a very tricky one. From 60 to 65 is how much? 5. And from 65 to 75 is what? 10. And from 75 to 85 is 10. However, this is what they did on this one. They are from 1 to 2, it's 5. But then from 2 to 4, it is 10. But what did they did here? They skipped a number. So if I put in 3, what number would go here? 70. So does it still fit the pattern? Yeah. What number do they skip here? 5. So they skipped 80. So if I add in the missing numbers, then it would be 5, 5, 5, 5, which makes it what? Constant. So C. Okay. So you really got to think about some of them. All right, number right, which of the following situations would represent exponential growth or decay? Growth means it's doing what? That's another way to say that. It's increasing. Decay would just mean it's decreasing. All right, so the keyword is exponential. Circle that, please. Keyword is exponential. All right, A says Sam mows the neighbor's yard each week for $20. So what does he get every week? $20. That means he's getting a constant amount of money. It's staying 20. Okay? Does constant fit the definition of exponential? No. So A doesn't work. Okay? B, Suzanne is raising money for the senior trip. She sells candy bars and makes $30 each week. So every week she's making the same amount. She's making $30. Is that exponential? No. Exponential is not constant. All right. C, Brittany earned $500 mowing yards last summer and has put the money in a savings account which earns 8% interest. All right. What do we think about that one? We've got a percent. Okay. Percent is going to clue us into exponential. And let's just read D to make sure. Tyler earned 500 mowing yards last summer and put the money in a coffee can under his bed. Is his money going to change? No. All right. Okay. So the answer is C. Does anybody need me to explain that one further? Okay. And number 9. John has $100 in his piggy bank and he puts $10 in it each week. Stephen A., what do you think? Nope, because he's putting in the same amount every week and we're still doing exponential. B, Mary is trying to gain weight so she can join the wrestling team. She is currently gaining 3 pounds each week. Faith, what do you think about that one? Nope. All right. The last two you got to pay attention to. C says Sue is going shopping this weekend and she has a coupon for 10% off her entire purchase at Kohl's. The 10% is her what? Her coupon. How many times is she going to be able to use that coupon? Once. So is it going to be growth or decay? Is it going to be increasing or decreasing? No. Okay, let's look at this one. Jack is on the wrestling team and trying to get into a smaller weight class. He's losing 5% of his weight each week. His weight's going to change. Every week his weight is going to change. So which one is the best answer? D. All right, there's your Oreos.